Namaskar. Now last time we have observed how to construct the RS flip-flop using NOR gate or by using NAND gates. Now such a circuit is known as latch. It is referred as NOR gate latch or this is NAND gate latch. What is the reason? What is the reason behind this? The reason is interesting. Suppose if I draw the block diagram, here I will write here it is R, that is reset input, because the flip-flop gets reset. I will call this as set input. This is the main output of the flip-flop Qn. Actually there is no need to represent other output Qn bar because it should be complement of Qn always. But in case of RS flip-flop we represent it or we will draw this. The reason is that for the forbidden or illegal state both Qn and Qn bar are same. Actually it should not happen, but they are. Now what happens if I keep R to be equal to 0 and S to be equal to 1, then the flip-flop gets set. Now I will draw the timing diagram now. This is one more way of representation of working of digital electronic circuit. Therefore this is R input, this is S input, both are 0 0, correct? Both are 0 0. Now suppose R remains 0 and if I make S to be equal to 1, suppose S is equal to 1, then if I made both to be 0 0, both to be 0 0, 0 0, then I change the value of R to be 1 and kept S to be 0. Then again if I made both to be 0 0, both to be 0 0, and suppose if I made both to be 1 1, correct? And then again 0 0. Let the RS flip-flop, that is latch, is made up of NOR gate. Therefore NOR gate latch is there. It is made up of NOR gate. So what will happen? If R and S both are 0 0, in case of NOR gate, when R and S both are 0 0, we have mentioned that the output Qn remains as it is, same as the previous state, n minus first state. And similarly for Qn minus 1, bar remains previous. Okay. So here I don't know what is the previous state and I will represent it like this. It is Qn and obviously I will represent this Qn bar. Okay. This value is Qn minus 1 and this value is Qn minus 1 bar. Now it may be 0 or 1. We don't know what is the previous state output. So I am representing like this. But when S becomes 1, the flip-flop gets set. Check. When S is equal to 1, the output becomes 1 and it is known as the set state of flip-flop. So irrespective of previous output, now the output changes to 1, correct? It is 1 and the complement of output becomes 0. Qn bar becomes 0. Now again R and S are 0 0 somewhere here. But what happens if R and S are 0 0? The output remains as it is. Now it is 1, therefore it remains 1. Correct? It remains 1. What happens if R is equal to 1 and S is equal to 0? At this particular point, R is equal to 1 and S is equal to 0. Now we can observe that if R is equal to 1 and S is equal to 0, the flip-flop gets reset. What happened? This QN output is 0, it is reset. So here QN changes to 0, it becomes 0 and QN bar becomes 1. Again, if R and S becomes 0, 0, here they become 0, 0, but there is no change, it remains reset, QN bar remains 1. And if both are 1, 1, here we have observed, if both are 1, 1 input, then both outputs are 0, 0, both outputs are 0, 0, it is 0, 0, and this state is illegal, this is 0 and this is 0. So what happens when both are 0, 0? After that, they may not remain 0, 0. Now we will have to take care that they will not remain at 0, 0. Why? Now we will check. Suppose both inputs are 0, 0. This is 0. Then both inputs of second NOR gate are 0, 0 and output forces to become 1. Therefore, any one, either Qn or Qn bar, is forced to become 1. Is forced to become 1. So here it becomes 1, it remains 0. Or this becomes 1 and it remains 0. Therefore, any one of them, either it is 1, 0 or it is 0, 1. Correct? And that is with 50% probability. There is no compulsion that the flip-flop gets set or flip-flop gets reset. It is random. Such a representation is known as waveform representation of the output. Here it is sequential. What happens we can show. And here you will realize that whenever the both inputs are 0, 0, the flip-flop holds the previous state. Therefore, here it holds the set state. Here it holds the reset state. Check. R and S are 0, 0. It remains 0. Therefore, it remains reset. R and S are 0, 0. It remains set. And hence it is known as latch. Means, what we can do? We can make output either 0 and then keep R and S to be 0, 0, it remains 0. Or we may set the flip-flop by making S to be 1, Qn becomes 1, and then though we make R and S to be 0, 0, it 1 remains as it is. Therefore, output gets hold. Here it holds the set state. Here it holds the reset state. Though we make R and S to be 0, 0, hence it behaves like a latch. In our latch, when we use the key, then only we can change the state. Either we can open the door or we can close the door. Otherwise, no. Similarly, the output gets latched. It gets locked there. And whenever R and S are 0, 0, the state remains as it is. Hence, it is known as the latch circuit. Now, suppose we will have to use the similar inputs or the same inputs. This R input is to be used for the second flip-flop or second electronic circuit. Then is it possible to control this RS flip-flop? by some other input? The answer is yes. And such a circuit, electronic circuit, is known as gated circuit. Okay, gated circuit. That means some input is to be used as a gate, and then we can use the flip-flop as it is, provided that the gate is open. I will draw the flip-flop using NOR gate once again. Now this is my flip-flop using NOR gate once again. Correct? Again I will draw the feedback, cross feedback, and therefore it is something like this. Then I will add one more part. Here I will add the AND gate, means the R input is provided to the flip-flop. Basically this is our flip-flop. From this point onwards we will draw this as a block. We will not represent the internal part. There is S. Now suppose this is R, this is S, and this combined I will call it as gate. So this circuit is equivalent to, this is my RS flip-flop, R and S flip-flop, Qn and Qn bar. Then there is AND gate, this is R. Then there is AND gate, this is S, and this is my gate. These are equivalent. I have drawn this considering the RS flip-flop here in the form of a single block. Now can you test what is the role of gate? Prepare a table. Gate R, S, Qn and Qn bar. Now let it be homework for you right now.